Good morning, dear colleagues. The keywords of our presentation is the Caspian Sea, the Russian plain, and the last climatic macrocycle. It includes the time epoch between last and modern interglacier. The problem of correlation between transgressive-regressive events in the Caspian Sea and glacial interglacial events on the Russian plain is very important for the Pleistocene paleogeography, but it is under discussion yet. You see some schemes of the famous Russian scientists. You see that they are very, very, very different. I present our scheme, what material we use for our conclusion. We study main sections on the Lower Volga region. We study them but complex paleogeographical analysis. And we study drilling material from the northern Caspian Sea. We study 12 coals, 12 deep coals, up to 100 meters. The stratigraphy of our stratigraphic scheme is based on the Didacna genus mollusks. This genus is the index fossil for Ponto-Caspian region. So, the last climatic microcycle include climatic events, Imin or Mikulina in Russian scheme interglacier, early Valdai and late Valdai stages of the glacier, and interstadial Bryansk interstadial between them. Miss 5 or beginning of the late Pleistocene. In the Lower Volga region, the main section which we studied is the Srednya Akhtuba section near Volgograd. In the lower part of this section, you see three horizons of ancient soils. We obtain the OSL dating for these deposits, and we see that each soil horizon corresponds to the each one substage of the MIS 5. In the Caspian Sea. In the Caspian Sea, the beginning of the late Pleistocene is marked by the late Khazarian transgressive epoch. All paleogeographical proxies indicate this basin was small, warm, and isolated. It corresponds to Mikulina interglacier. According to drilling data, late Khazarian epoch proceeded in two stages: northern late Khazarian and Girkanian stages. Mollusk fauna from late Khazarian and from Girkanian deposits are very, very different each from other. And pollen proxies from Khazarian deposits indicate the dry, warm steppe in the surrounding territory. But the pollen proxies from Girkanian basin indicate more humid and more cooler climate. And we conclude that this basin developed during transition epoch between Mikulina and next glaciation. Our correlation. We correlate the late Khazarian basin with Mikulina integration in Russian plain, and we correlate Girkanian transgression with transition epoch between Mikulina interglacier and Valdai glacier. The structure of managed depression we see in this region the deposits with the late Khazarian, Karangatian, Girkatian, and Malakafona form a kind of layered pancake that inform about correlation these events. We know that Karangatian transgression of the Black Sea was a consequence of interglacial Imean transgression of the ocean. Is found in Grecian basin, deeply penetrated in the Manich Valley. Waters of Girkanian transgression penetrated in the Manich depression with Karangatian basin level dropped along with the aggression of the ocean as a transition to glacial epoch, and the Manich passage with Karangatian waters was open in this transition epoch. The next event is Attalian regression, deep Attalian regression. You see terrestrial Attalian deposits in the lower Volga region. The proxies, pollen proxies, include dark taiga, and these deposits contain a faunistic complex with mammals, reindeer, and other animals. In the lower part of these deposits, you see ice wedges. They penetrated in the ancient soil. Because of this data, on the basis of this data, we conclude that Attalian regression, beginning of late Attalian regression, was developed during the Kalinin or Elio-Valdai glaciation. We obtained OSL data from upper part of the Attalian deposits, and we see that the end of Attalian regression took place during the first part of the Mis-3 in the Warman epoch, corresponding to Mis-3. What about drilling material? In the structure of the cores, we see that Attalian deposits, the data of Attalian deposits, radiocarbon data of Attalian deposits correspond to the end of Mis-3-2. On this base, we correlate the Attalian regression in the Caspian Sea with Kalinin glacial epoch or Elio-Valdai glacial epoch, and first part of the interstitial warming during Mis-3. In the Pontian basin, it was post-Karangatian regression 2. The next event. We see the deposits of these events in the structure of the northern Caspian coast. We have many radiocarbon dating of these deposits. They correspond to second part of the Mis-3. In the second part of this warm epoch. In the lower Volga region, there are alluvial deposits formed during this time. The OSL dating are in the good agreement with radiocarbon dating from the northern Caspian coast. And in the upper part of Attalian deposit, well spread the Bryansk ancient soil. On this base, we correlate the second part of the interstadial warming Mis-3 with the first stage of the early Hvalinian transgression in the Caspian Sea. In the Black Sea, it was small Suraj transgression. Our colleague, paleogeomorphologist Andrei Panin, conclude the epoch of so-called pluvial epoch for Russian plain, and it developed during the same The next event, LGM. In the structure of course, we see the regression layer corresponding to this event with radiocarbon dating. In the terrestrial deposits, we don't see the deposits correspond to this event. We conclude they will wash out during the next transgressive regressive event. So we correlate the LGM with regressive stage in the Caspian Sea. In the Black Sea, it was New Euxinian regression too. In the lower part of the slide, you see the picture, the modeling of the results of climatic modeling, but the next speaker, Alexander Kislov, this modeling is in the good agreement with our paleogeographical conclusion. The next event, the epoch of degradation of the late Valdai glacial stage. We see small layer, thick layer of the transgressive deposits in the structure of the Caspian coast. This was the first stage of degradation of the late Valdai stage. After this layer, we see unconformity, and under it, the layer of clay layer with numerous radiocarbon dating. They correspond to the next stage of the degradation. The unconformity correspond to oldest dryas called epoch. This degradation, the second event of degradation of the late Valdai glacial stage, we see reflected in the transgressive deposits in the Caspian coast. We have numerous radiocarbon dating. This event correspond to Berling and Aleriot warming in the Russian plain. In the lower Volga section, we see the characteristic chocolate clays. They was accumulating in the Volga estuarine in the depressions of pre-Hvalinian relief, presumably due to active southern of permafrost and great mass of fine material brought by the rivers. You see in this slide the Hvalinian chocolate clays with sandy prolayer with Hvalinian fauna in them. This chocolate clay is very specific deposits of the Caspian Sea, very unicum deposits. Radiocarbon dating and OSL dating of these events in the Caspian Sea and in the terrestrial section are in very good agreement each with other. So we conclude the epoch of degradation of the late Valdai glacial stage corresponding to the time of sea level rise in the Caspian Sea. Our colleague paleogeomorphologist Andrei Panin for this epoch reconstruct the so-called pluvial epoch in the Russian plain too. The next epoch is a cooling, short cool event, younger dryas. In the structure of the Caspian coast, we see the regressive layer with radiocarbon dating. I think that is Yanataysk regression between early Hvalinian and late Hvalinian events. And the last transgressive events during Hvalinian epoch is the late Hvalinian transgression. Islamic Parthenon transgression correspond to the epoch on warming because after younger dress cold event. Palynological data provide evidence of a general warming in the region too. Faunistic, microfaunistic proxies suggest the warm basin too. It was the last Hvalinian transgressive event in the Caspian Sea. The next event took place in the beginning of Holocene. In the boreal period of Holocene, it was Mangelschlag regression of the Caspian Sea. In the structure of northern Caspian deposits, we see the deep paleo depression corresponding to this event. With sediment, with freshwater, terrestrial mollusk, with plants, and another evidence of terrestrial situation. The numerous radiocarbon dating of this event evidence about this event took place during the beginning of the Holocene epoch. As conclude our conclusion, you see in this slide. In the picture, we see all situation in the Caspian Sea, the Caspian evolution during the last climatic microcycle. You see different position of the level of the Caspian Sea, and it will be very interesting to compare the position of the level of the closed Caspian Sea, lacustrine Caspian Sea, and open marine Black Sea, and you see the compare of the evolution of the Caspian Sea with the evolution of the Black Sea in that time interval, and you see the correlation of the events in the Caspian Sea with glacial, interglacial events and its stages on the Russian plain, and the global climate change from A to H, from Mikulina transitional epoch between interglacial to Early-Valdai transgression, between maximum of Early-Valdai glacier, the second half of the Ms number 3 warming, the LGM epoch, the epoch of degradation of the late Valdai transgression, the next stages of the degradation of the late Valdai stages, and the beginning of Holocene, the boreal period of Holocene, the Mangelschlag regression of the Caspian Sea. Thank you. Sorry, my time is over some minutes ago, because I am ready to answer your question under this session. I am ready to answer your question under this session. Sorry. Thank you.
So, dear colleagues, I will continue discussing the level dynamics, which was started from Yanina, but I will concentrate on the origin of these fluctuations. As a result of many years in the framework of successive projects, a large set of multidisciplinary data has been accumulated. Motivated by this observational tide, we survey the basic principles governing the long-lived sea level anomalies, having left traces in the form of transgression and regressions. During the Holocene, the Caspian Sea was a closed lake separating by seal from the Black Sea. Sometimes the Caspian Sea level rise so high that the Caspian Sea overflowed to the Black Sea from the managed strait. In closed stage, the level fluctuations depend on regional scale climate variations. So such seas could be treated as natural laboratories, allow us to explore a reaction of its regime on the global climate changes. However, synthesis of this data by their simulation by models imply one fundamental problem. Some paleo-evidence seem to contradict each other. We call these contradictions paradoxes and discuss them in this presentation with a hope to encourage a new round of research that could lead to a deeper understanding of our knowledge. I'll start with recognizing of three paradoxes. The first one is devoted to so-called Chvalinian transgressions. Main question is what was source for additional water needed to providing the early and late Chvalinian transgressions. Paradox number two concerns the fact that the climatically induced level fluctuations during the Holocene poorly correlate to calendar of climate events. Paradox number three is devoted to the fact that massive water exchange via Bosphorus Strait and simultaneously large Black Sea level fluctuations couldn't coexist in the same epoch. So goal of my presentation is to clarify these paradoxes, to provide some ideas how we can be solved. We'll start with first paradox. This is a map denoting different stages of the Caspian Sea. Our colleagues demonstrated, based on geomorphological evidence, that rivers adhering to the Volga basin brought much more water to Chvalinian time compared to present time. Hence, the source of additional water was on the East European plain. It is an important fact that allows us to exclude other potential water source regions. A major question is what was source for additional water? We are faced with a paradox. The event was, but it was inexplicable. Indeed, model experiments don't support that precipitation substantially increased. The melting water contribution is excluded. A realization of huge stochastic anomaly is not possible. My colleagues proposed that water volume flowing along the rivers increased significantly due to an increase of the runoff coefficient. This could be due to a decrease in the rate of infiltration into the soil of the catchment area due to permafrost inherited from the LGM. However, so far this is only a hypothesis. I'll start the discussion of the second paradox. There is a fact of the correlation between level changes and climatic variables during the Holocene. A major question is how the Caspian Sea level area depends on the climate forcing. Will the system responding to the climate change develop a chaotically changes of level? How we can quantitatively describe such behavior? To explore variability of the Caspian Sea, we use deterministic equation of water budget. The right-hand side of equation consists of inflow and outflow and evaporation minus precipitation over the sea area, a bit of algebra utilizing the relation between area and level yields the equation in such form. Okay, in the middle of the slide. The properties of this equation allow us to consider this equation as stochastic one, proposing that slow changes over age are balanced by statistically average result of the fast fluctuations. How does such adjustment work? Consecutive positive and negative anomalies of water budget don't completely cancel each other out, and the residual effect accumulate. This forms, step by step, a large deviation from the initial state. We have set the variance as function of time and variance in stable steady-state conditions. Let us pause for a moment to evaluate this climb. This is a joke example of such a random walk. You can see a drunken sailor came out of a bar, chaotically walks during time along the beach. The standard deviation from door of bar is proportional to the square root of the time. The Caspian sea level changes have the same mechanism. They look like a self-propelled Gaussian noise. So these regular fluctuations are not required to follow the fast climatic events. Please keep in mind that this conclusion based on simplified physics, but we are sure that detailed calculation, which possibly will be realized in the future, don't change things much. It is a supplementary information. It was established with parameters determining the probability distribution function and typical time of the level fluctuations, a function of position on the hypsographic curve. But you can see in all cases, super large anomalies are practically impossible. It means that huge anomalies, like the Hvalinian transgressions, could not be provided by such mechanism. But observed changes of the Caspian Sea under the Holocene could result from the accumulation of small anomalies in the water regime. I'll start the discussion of the third paradox. When looking in this figure, you can see one finds that half of the curves demonstrate continuous rise without cyclic fluctuations. The other half of the curves have strong variations denoting a complex series of transgressions and regressions identified in the paleogeographic records. The essence of such paradox is that these facts contradict to each other. So, reconstructed large water discharge from the Black Sea via the Bosphorus Strait and another view about fluctuating character of Black Sea level. These facts are contradicts to each other because we could not coexist simultaneously. To investigate it, we return to a mathematical apparatus which was realized earlier. Returning to equation for water budget. If the water exchange via the Bosphorus Strait was such as was reconstructed, was so large, it would be a very effective mechanism destroying the Black Sea level anomalies, rendering the level stable. The decay time of anomalies is approximately 5 years. Therefore, solution for such situation exhibits no sea level variations. Conclusion. Paradox number 2 has been solved, at least on conception level. Solution of the paradox number 1 and paradox number 3 are absent. Further geological and geochronological evidence as well as climate simulation are required. Formulation and solution of paradoxes should make a major contribution not only to the problems of the paleogeography of the Caspian Sea, Black Sea, but also help us to explain the reasons for the inadequate simulation of regional climate change. This is important in the context of the development of models to future climate prediction. Thank you.
Dear colleagues, first of all, I want to thank organizers of conference for support and the invitation me to Zaragoza meeting. My report is a contribution to the IGCP project from the Caspian Sea to the Mediterranean during the Quaternary. My work is devoted to climatic reconstruction of the upper Pleistocene on the basis of pollen data in the North Caucasus. The area of research from the Caspian Sea coast in the east, the foothills of the Great Caucasus in the Dagestan, in the west throughout Chechnya to Pyatigorsk. Upper Pliocene or the regional Akchigirian deposits are widely distributed within the southern part of the Russian plain or East European plain. The area of research is located in the extreme south of the plain and covers the three areas: the Mineralny Vod region, the Tersk-Sunzhensk area, and the Dagestan foothills. In the late Pliocene, there was an Akchigirian sea here. It isn't known yet as far to the north it spread and whether there was a connection with the Black Sea with the World Ocean. Focus on stratigraphic status of the Caspian regional stage and the relations of European Pliocene-Pleistocene staging, reconstruction of the environments and climate stratigraphic interpretation of the pollen data. Until now, stratigraphic status of the Akchigirian and the Reproduction has not been defined. The basis of the Mediterranean plain change is approximately comparable to the beginning of the Akchigirian of the Caspian region, coincide with the change of paleomagnetic epochs Gilbert Gauss. The international and domestic stratigraphic subdivision of the Quaternary system in Russia remain under discussion. The studied area is located in northern Precaspian's northeast. We can see location map and late Pliocene geological map of the study area showing the investigated region. Several cores and outgrowths in the northern Caspian area were studied for palynology. In the Akchigirian key sections of northern Caspian on northern Caucasus Zambos, for pollen analysis were selected from faunistic characterized sections. Pollen well remains in sediments. It's the indicator of changes of vegetation, flora, and climate from 10 to many millions of years. Several key questions were resolved. Several pollen diagrams are made. Alexandria borehole is the basic for all North Caucasus. Pollen of the mid-Akchigirian spectra shows that in the mid-Akchigirian forests were characterized by the maximum diversity of coniferous species, such as Abies, Pizza, Pinus, and Tsuga. Light micrographs of pollen grains of coniferous trees. Pollen of broadleaf trees and subtropical species. Pollen diagram for CEREGE borehole. At the end of the Neolithic Chigurin, the warm pollen spectra and the warm interval is located. The pollen diagram of alder cold spectra of steppe and pine forest in the mid-Chigulian. On the Chechenian pollen diagram, warm spectra at the end of Neolithic Chigurin is located. The broad-leafed forest with the maximum variety developed. The structured dendroflora testified to a warm, humid climate. According to the pollen diagram, 6 pollen zones are allocated. Alternation of phases in vegetation refers change of climatic condition. Phases of prevalence of forest vegetation correspond to humid and warm epochs. Phases of treeless vegetation correspond to dry and cool epochs. Pollen of herbs which reflect steppe vegetation. The pollen diagram of Itoka, Neopetygorsk, the Lake Tambukan, coniferous forest with a hemlock in the mid-Chigurin. It's cool and wet. On the basis of studying of many pollen diagrams, it's established that several events are established in a late Pleistocene in the North Caucasus. The first significant climatic cooling corresponds with the beginning of the Chigurin with the Gilbert-Gauss paramagnetic inversion and with an important change in the main flora elements. A more significant cooling corresponds with the beginning of the Upper Chigurin and the Gauss-Motoyama paramagnetic inversion at the end of the Pliocene. The events are defined on the basis of allocation of warm and cold pollen spectra, which are given in the table. This table reflects history of development of vegetation of North Caucasus throughout the late Pleistocene. Comparison of pollen diagram of Northern Caucasus and the south of the Mediterranean has shown that the vegetation of the North Caucasus shows changes consistent with climatic warming at around 3.2 million years ago, which coincides with the period of warming in the Mediterranean and probably represents the mid-Pliocene warm period. This is the first evidence for the event yet found in the Caspian region. For early Chigurin forests were characterized by the maximum diversity of arboreal species. Pollen from group 1 and 2 shows that the climate was moderately warm and quite humid. A cooling trend is evident in the mid-Chigurin. This is demonstrated by an increased abundance of coniferous species, the occurrence of forest taiga forms, and the reduced quantity of thermophilic elements. Towards the early Pshironian, a tendency of more continental arid climate is noted. Pollen of trees from 4 groups only. There were reduction in the proportion of thermophilic elements throughout the Chigulian. It's established that in the Chigulian the forests were replaced by steppes of 5 times. During the Chigulian and the Pshironian there was a succession of changes in the relationship between the geographical elements of the dendroflora and the role of thermophilic elements decreased. In the Mediterranean was a transition from a subtropical climate with wet summer to a climate with a dry summer season. In southern Western Europe, the first dry phase occurred by Suk In the southeast of the Russian plain, the North Caspian region, the beginning of the Mid-October was marked by frequent alternating phases of arid and humid climate. Such alterations are characteristic of the Quaternary and are reflected in a change between forest and steppe vegetation. Against the background of general cooling and drying of the climate, there were smaller scale fluctuations in temperature and humidity. It's revealed that forests of the early October were characterized by the maximum diversity of arboreal species. A cooling trend is evident in the mid-October. This is demonstrated by an increased abundance of coniferous species and the reduced quantity of thermophilic elements. In the late October and in the early Apsheronian, we are an intensification of the continental climate and an increase in aridity. Xerophytic Chenopodiaceae artemisia steppe landscape predominated. The conclusion is drawn that coniferous and broad-leaved forests developed at times of maximum Octogorian transgression in response to cool temperatures and increased humidity. Contraction of the Paleocaspian Sea was associated with increased aridity and the development of treeless landscapes. For the first time, according to pollen data, vegetation zonality is reconstructed. If in the basin of Paleo-Volga and the Paleo-Ural the taiga dominated, then steppes in the south prevailed. In the south of the North Caucasus, steppes were replaced by the coniferous and broad-leaved forests, and in the foothills of Caucasus, the oak forests grew. In the conclusions, it's necessary to tell that on the basis of pollen assemblages and sediment cores and outcrops from the North Caucasus, climatic fluctuations and related changes in vegetation can be recognized for the time of early Pleistocene. The main conclusion of pollinological study are: the first significant climatic cooling occurred at the beginning of the October, the Gilbert-Gauss paramagnetic inversion, and with an important change in the main floral elements. A more significant cooling corresponds with the beginning of the upper October and the Gauss-Motoyama paramagnetic inversion at the end of the Pliocene. Evidence from the pollen studies shows that climatic warming occurred at around 3.2 million years ago in the North Caucasus, coincides with the period of warming in the southern Europe and the mid-Pliocene warm period. This is the first evidence for the warming yet found in the Caspian region. New data have been published in the Quaternary International. This article and this my report are contribution to the project From the Caspian to the Mediterranean during the Quaternary, sponsored by UNESCO. Thank you very much.
This is a paper on behalf of a group of us who've been working on the question of the relationship between environmental changes during the last glacial interglacial transition and the beginnings of agriculture. I'm sure, as most people here know, the area of the Eastern Mediterranean is one of the oldest and most important areas of plant and animal domestication, involving cereal crops and a variety of livestock, sheep, goat, cattle, pig. And archaeologically, these are associated with pre-pottery Neolithic sites, particularly those attributed to the so-called pre-pottery Neolithic B period from around 10,000 calendar years ago. And this is associated with all sorts of developments in material culture, sedentism, village life, and so forth at sites such as Ashikluhiyuk on the left here and Çatalhöyük on the right, both in south-central Anatolia. The fact that farming first began in this part of the world in the very early Holocene has not gone unnoticed, and the fact that that coincided or occurred soon after the last global warming, the major climatic transition at the end of the last ice age, And as way back as 1908, Rafael Pompelli, who you can see here, got the Best Beard of the Year award for the year 1907, following Karl Marx, suggested, basing his work in actually Central Asia rather than Southwest Asia, that he'd seen evidence of climatic desiccation in the landscape, not well dated at that stage, but nonetheless one that he interpreted as indicating a contraction in water resources. And Gordon Childs, some decades later, and others, took those ideas to link them to his proposed Neolithic revolution, in which he argued that the supposed pluvial climatic conditions, the wet climatic conditions that were then thought to be associated with glacial climates, as they moved towards the Holocene, if that was associated with climatic desiccation, reduced area of water resources, so people, animals and plants would have been forced to live in ever closer proximity, and that new relationship was suggested to have led on to domestication. The first proper test of those ideas came in the 1950s, particularly with the work of American archaeologist Robert Braidwood, who excavated the site of Jarmo in northern Iraq. And Braidwood took with him the geologist Herb Wright. And Herb Wright went looking for evidence of glaciation, which he found, but more importantly, he also did some pioneering lake coring. And in particular, he cored a lake just across the border into Iran called Lake Zeriba. It was those cores, which go back to, in fact, before the last glacial maximum, were subject to quite a wide range of what we would now call multi-proxy analyses, including work by Evelyn Hutchinson on geochemistry, but perhaps more pertinent to today, the samples were also analysed for pollen by Wim van Zeist from Groningen University in the Netherlands. Van Zeist, like Herb Wright, died relatively recently, both in their 1990s. As you can see from the pollen diagram on the left-hand side there, which goes back about 12 or 13,000 years, the overall tendency in the record is one of which tree pollen increases during the transition from late glacial into Holocene times. And that change was exactly the reverse of that which was proposed by the likes of Child. In other words, the suggestion was, rather than getting drier, the increase in forests were indicative of a climate that became wetter. And that appeared, at least, to give a lie and to falsify the oasis hypothesis. However, it did re-emerge a little bit later, linked to the work at the site of Tel Abu Huraira, which is on the Euphrates, now underwater, close to the centre of ISIS in Raqqa. And Andrew Moore and Gordon Hillman, working there, found that this site, which has a continuous occupation from before the Younger Dryas through into the early Holocene, showed evidence of a change in resource use, which indicated aridity and a decrease in cereals during the Younger Dryas, so that they, rather than seeing the Holocene as the period of desiccation and contracting resources, instead they used the Younger Dryas as the trigger for that change. So, with that as a kind of context, what I want to move on to now is to deal briefly with a summary of what we know about contemporary evidence for climate change, particularly from isotopes, also to look at history of vegetation, a little bit of modelling, and some archaeological data on paleodemography. So, is this going to work? Yes? Okay. So if we take isotope records from lakes at the top and cave sequences from the Eastern Mediterranean there, what strikes one about that is that the pattern of change going from left to right is one in which there wasn't a linear change from glacial to interglacial climate, but one which was interrupted by exactly the same pattern of reversal that you see elsewhere in the Northern Hemisphere, for example, in the Greenland ice core record, which is shown on the bottom. Now, there are differences in the timing, for sure, but I think almost certainly most, if not all of those, relate to imprecisions in chronology rather than a change in pattern. If we make that assumption, then we could then take data for each of the defined periods. So the periods I'm going to use here are Heinrich I, the very end of the glacial period, the Berling-Alleröd interstadial, the Younger Dryas interstadial, and then the early Holocene, which I've divided into two periods, a first period and a second period. And if we take the isotope data here and we combine them for each of those periods and we plot them on the graph, which you can see on the right there, that gives us an idea of, and put them into Z-scores, it gives us an idea of how much of the climate change was accomplished during each phase. And very broadly, it suggests that during the Berling-Alleröd, there was about 2/3 of the full interglacial warming. There was then a reversal to about 1/3 of the value during the Younger Dryas before reaching full interglacial values early in the Holocene. I would, before, put some constraints on that, in that the scatter of data, particularly for the Berling-Alleröd, is relatively broad. We see essentially a very similar pattern when we look at the vegetation evidence, in this case from pollen. This takes Chenopodiaceae and Artemisia, steppe herbs, and shows that essentially they were more abundant, as in Zeribar during glacial times, and reduced in importance during the Holocene. There's some signs of reversal, but less clear than in the isotopes. And the reverse pattern is found in tree pollen. This is oak, the most common tree in Southwest Asia, which increased over time. There is a lag effect in the Holocene, which was mentioned at this session yesterday, for example, by Erwin Messager, and I'm not going to spend time discussing the details of that now. But overall, the pattern was an increase. If we look at an alternative source of data, this is charcoal from archaeological sites, and this is from about combined from about 20 to 25 archaeological records where the charcoals have been analysed for their woody species. Obviously, this only covers trees, not the non-arboreal pollen. You can see some similarities to the pollen. For example, the oak pollen, which is shown in green, is absent in the late glacial and begins to appear in the Holocene. But there's also some interesting differences, partly related to the fact that pollen doesn't record all woody plants. Things like almond, amygdalus, is not recorded because it doesn't produce pollen. An interesting one is Pistacia, which is shown in red on here and is quite common, particularly as we move from the late glacial into the Holocene in a number of areas, and several pollen diagrams do show that same trend. Pistacia is not a big producer of pollen, so the absolute values are quite low, but nonetheless, Pistacia was clearly quite a significant element of the ground flora in the early Holocene in particular. So perhaps the most important summary from the vegetation part is that there was a clear transition in vegetation, clearly linked to climate, but there was also this very interesting early Holocene phase of what we might call parkland, with some trees, oak, pistacia, almond, but also quite extensive grassland within which wild cereals would have been a major part. If we take the climate data that I showed 2 slides ago, we can then see what the impact of those climate changes would have been geographically across Southwest Asia. So I've taken here the Climatic Research Unit gridded data set and specified some very simple rules about what I call the oikumene, and by that I mean the area in which, for example, both wild or cultivated cereals might have grown. And the thresholds I've taken here are a mean annual precipitation of 240 millimetres a year, or 20 millimetres a month, and a temperature in the winter, a mean temperature in the winter above -2 degrees Celsius. If we take the climate data that I showed before, and you can see them listed next to each of these periods, there's obviously some uncertainty about them, but I think they're relatively robust. If we take those and apply those geographically, then what comes out is that clearly there was an expansion in the oikumene during warm periods and a contraction during cold periods. But more interestingly, I think we can see how some areas, and the southern Levant is a case in point, and I've highlighted that there, the southern Levant actually shows continuity all the way through. So there was the climatic conditions were at all stages, from the glacial through into the interglacial, suitable for cereal growth and cereal cultivation, and there was obviously the potential for continuity of settlement to go with that. By contrast, central Anatolia was only habitable during warm periods. In cold periods, including the Younger Dryas, it was simply too cold. Perhaps most interesting of all, though, is the northern Levant, or northern Mesopotamia, which shows certainly the potential for cereal growth and farming based on cereals during warm phases, the interstadial and the early Holocene, but almost certainly probably also during the Younger Dryas. Even if you drop the temperature a bit, you'll still find that that area would have been within the habitable area. So there's evidence that the northern Levant actually had continuity from right the way through the Younger Dryas in terms of the climate constraints. Moving from the climate data now to the archaeology, one way of trying to assess the impacts is to look at archaeological periodization, and my next slide will just briefly show that. But I think an alternative approach, which has become increasingly used by archaeologists, is to use dates as data, radiocarbon dates as data, and look at their probability density functions over time. So if we take all the available Eastern Mediterranean radiocarbon dates for this period, about 2,000 of them, you can see the pattern here. And the pattern is one in which there's an increase over time, but marked in blue are periods which were below the range, the expected range, and periods marked in red are periods above it. So for the whole area, you can see that the one period that's above it is at the climatic transition at the start of the Holocene, and the one period that's below it is in the deterioration leading into the Younger Dryas, which suggests some kind of synchronicity with climate. Once we break it down into subregions, however, a more interesting and complicated pattern emerges. The pattern that we see there is not replicated in all three regions. The initial warming of the Berling-Alra only leads to an expansion of settlement and population in the southern Levant. Right? In the northern Levant, the major period which was outside the range is the one following the Younger Dryas. And in central Anatolia, there is no occupation at all, no dated archaeological occupation at all during the Younger Dryas. So thus we've got some interesting interregional contrasts during the Younger Dryas. There's a continuous growth in population through both the northern and southern Levant at the same time that there was abandonment in Anatolia. That matches the climate models, the climate scenarios I showed in the previous slide. There's an opportunistic growth in population linked to the climatic amelioration at the start of the Holocene, but in the case of Anatolia, that's lagged by at least several centuries. And then once we move into the early Holocene, you have a rather curious kind of boom and bust pattern, which shows opposite trends in different areas, which almost certainly cannot be climatically controlled because the climatic changes would have been essentially synchronous across that whole area. I'm running a little short on time, so I won't elaborate on this, but essentially to say there has been a lot of previous work trying to look at the synchronism between cultural phases and climate, and certainly some of the major cultural phases match the sharpest periods of warming at the start of the, sorry, this is going from right to left, I'm afraid, rather than left to right, but there's the onset, for example, the start of the Natufian period within the range of dating and precision, coinciding with the initial warming at the start of the interstadial. Similarly, the start of the Neolithic is marked by the end of the Younger Dryas period. On the other hand, for example, farming proper didn't begin at the beginning of the Holocene. It was only 1,000 to 2,000 years later, and therefore there was, in those terms, a significant lag between any climate change and adoption of the new mode of production. So, in conclusion, what role did climate changes play in the transition to Neolithic agriculture in Southwest Asia? I think we can say that in some cases there were links which were quite direct. Those periods of abrupt warming coincide with major cultural changes. Sometimes there were links, but they were indirect. For example, the fact that during the Younger Dryas you had continuity in the Levant, but not in south-central Anatolia, which can be related to the fact that key thresholds were crossed in one area climatically, but not in the other. But also there are periods, such as the adoption of farming in the PPNB around 11,000 and 10,000 years ago, which seems to show no synchronism with climate. So sometimes direct, sometimes indirect, sometimes not at all. Thank you.
So, ladies and gentlemen, my talk is about Bronze Age settlement mounds on the Colchian Plain and the Black Sea coast of Georgia. The settlement form of mounds is known from the whole old world, originating from the Fertile Crescent and spreading over the last 10,000 years to, like Europe, Middle East, Africa, and even in America. There are some variations called platform mounts known. In Georgia, there are about 50 to 60 mounts we already know from satellite pictures and aerial pictures, like you can see here on the bottom. And even if you're in fields, these typical dwelling forms are obvious. Unfortunately, nowadays, up to now, there's no international or peer-ranked publication on the internal structure of the mounds, though there are some archaeological excavations, but they were conducted about 20 or 30 years ago. So, arising from this situation, we've got the following key questions. We want to know how old are these mounds. So, to solve that question, we need to establish a chronostratigraphy, mainly based on radiocarbon dating. We want to know more about their occupation. So, means, are there phases of construction or occupation visible? Can we also identify gaps in the occupation? And how were these mounds built? The crucial question here is, are these mounds tells? So that means that they were just like places where people settled for centuries, and we've got settlement layer and settlement layers which made them higher and gave them their recent structure. Or are they intentional constructed dwelling forms where people put intentionally material on a hill to settle on maybe dry feed or fortification reasons on top? And finally, for sure, we are dealing with paleo-environmental questions. Under which conditions, in terms of climate and environment, lived their inhabitants on these mounds? To solve these questions, we chose altogether 3 settlement mounds you can see here on the pictures from the Georgian area. They are all located in the northern part of the central Colchian plain. We chose these mounds under following conditions. Many of them are nowadays in use, like grounds for settlement, for farming houses, or also graveyards, and for sure these uses forbid further drillings or excavations from our side, and it's also in question of stratigraphy, no use on working these sites. So in these sites here you see the 2 mounds of Urulu 1 and Urulu 2 on the top picture. Urulu 1 on the right in the top, and Urulu 2, it's not that obvious from the air, but you see the red dots which mark the drilling points where we brought down our sediment cores. So what did we do to solve all these questions we asked some slides before? Our research is mainly based on sediment cores. You can see us drilling there, and you see what these cores look like when we got them out of the earth, and we can describe the different layers. Furthermore, we worked with aerial pictures taken by a drone to do structure from motion technique to get dry deep projections out of the mounds. Due to the short time slot, I cannot go into detail on these techniques, but just a short overview about what we did with the sediment samples. We tried to identify different fascias, so basically which layers are deposited from humans, so anthropogenic, and where do we have natural deposits. We can divide it all together in 3 fascias. We have 2 natural ones. It's fluvial samples, like river stream deposits, and alluvial samples, which dominate here. For sure, it's a coastal floodplain, so that's not a big surprise. But finally, with these principal component analysis, we were able to differentiate anthropogenic from natural sediments. We chose here 5 parameters of main grain size to differentiate between the coarse fluvial deposits and the fine-grained alluvial deposits, and added some indicators for human activity, so phosphorus for cattle, for animal husbandry, and copper and zinc for human activity like metallurgy. What came out with all these methods and research we did? Here are the results from settlement Mount Urulu 1. You can see it now also in the field. It's not that high, so sometimes if there's a lot of forest, it's not that easy to discover. We have here our chronostratigraphy build. You can see on the leftmost page our stratigraphy, and also there's a clear separation between natural and anthropogenic sediments obvious. It's because of flitters of burnt clay, because of some small but very rare macro remains, but also in the geochemistry. You see in the third line that the sorting is increasing, so that means it's less sorted in the anthropogenic layers, and especially phosphorus, which you can see more or less in the middle or more to the right, is increasing as well as the metals like copper and zinc, so the human indicators for human activity. In this case, it's also obvious in the sediment cores. You see a clear separation of these dark floodplain sediments and the rust-colored sediments of anthropogenic layers of the settlement mound itself. If we go on to the second settlement mound at that site, to Mount Arulu 2, we have a similar impression, though it's not that obvious in the picture of the sediment cores. But if we take a closer look at the sedimentology and stratigraphy, we also see here these increasing phosphorus, increasing metal ions, and also decreasing calcium-potassium ratio. To sum up the results from that Arulu site, by the way, Arulu is the name of the closest village, that's why we chose that fancy name. We see these two settlement mounds in their natural environment. From the radiocarbon datings, we see that the oldest settlement layer we dated are more or less first half of the second millennium BC, and the youngest are the second half of second millennium BC. And it's very similar to settlement mound Arulu 2, though here there's not such a big difference between the initial construction and the youngest dated anthropogenic layers. And what we can see, these two settlement mounds were constructed on an alluvial floodplain. We see a dominance of these fine-grained alluvial sediments intercalated by some stream current deposits of the rivers. Changing now to the second location, to settlement Mount Ageta 1, which is located close to the small village of Ageta. We also drilled here at the top of the settlement mound, but went a bit deeper to get more impression of the foundation ground too. And you see in the right corner below that we also worked here with the structure from motion techniques, so with the aerial photos taken by a drone. But let's at first have a look at the chronostratigraphy. We also see a clear separation of natural and anthropogenic sediments. Also here, metal ions are also increasing in with different peaks, which derives from different mobility of lead, of copper and tin. You also see an increase of phosphorus and a decreasing calcium and potassium ratio. We wanted to know, beside all this geochemistry, how big are these mounds and where does the material come from? So that's why we did this structure from motion technique, and you see here now an aerial picture. And the mound got a surface for more or less 1,200 square meters. It is surrounded by a moat of 6,600 square meters. And if you see, take a closer look at the cross sections, you see there's some kind of, not only the small ditch you can see around it, but between the ditch and the mound, we see that there's a circular depression. And it occurs like that there's the sediment coming from which was used for constructing these mounds. If we, and furthermore, a 3D projection. If you compare this settlement mound now to tells, we know from the last talk we already saw that there are plenty of in Anatolia, for example. We see the Georgian examples are rather small, so it seems like there's some kind of different construction, another point against the theory that there could be tells. We tried to put all what we found out into a bigger context of the Colchian, also Western Georgian region. You see on the left the settlement mounds with the dated materials, so they were constructed in the first half of the second millennium, sorry. So that meaning in the early Bronze Age, when the Colchian culture evolved. And if we compare that to the vegetation history, and climate conditions, we know from different publications which were conducted a bit further south, but under comparable circumstances, we see that these mounds were constructed in a very humid climate and very warm and humid conditions. So, coming to an end and summing up our questions, we wanted to know how old these settle mounds are. So the initial construction took place in the early Bronze Age, in the first half of second millennium. In case of Ergeta, it's a bit younger, but although it's second millennium BC. What do we know about the occupation? So at least they were occupied since that time, and in 3 cases of that 2 settlement mounds, there's not a big difference between the youngest and the oldest ages. Nevertheless, we know from literature, like ancient historians like Strabo or Pseudo-Skymnos, that people in that region lived still on dwelling forms in swampy forests. So that fits very well together with what we know from the further studies. How are these mounds built? Only based on the sedimentology, we cannot exclude or determine a certain way of building, like are these mounds now tells or intentional constructed. But if we include all the other information we have, so that is human swampy conditions around, that these mounds are very small in comparison to classical tells from Anatolia, it seems more or less obvious that they were intentionally constructed. And I guess everybody can understand, if you are settling in a swamp, you don't like to have wet feet at home, so you settle a bit higher. That comes to the last point, the environmental conditions. It seems like that there are, since 3500 BC at least, prevailed extensive wetlands. And also in the other publications I mentioned, is written from pollen records that it's really humid, warm, and swampy area. So that's our main point for these intentional constructed mounds. So if you have any further questions, I'll be happy to answer them right here or maybe in coffee break as you like, and thank you very much for your attention.
Thank you.
Good morning, everyone, and thank you very much for being here. I'm going to present the research, the results of our research funded by the British Academy. And the title is Paleo-Environmental Changes and Meso-Neolithic Human Landscape Interactions in the Caspian Coast. My co-author is Arash Amini from University of Golestan, and he was the one discovering the site I have studied. So we are in the southeast corner of the Caspian Sea, and the southern part of the Caspian Sea is an area of relatively high precipitation, and it's very important because it allows vegetation development, maintains human life already for a very long time. And you can see that in general this area is quite isolated. It's in an otherwise relatively dry area. The humidity comes mostly from the Caspian Sea, where the water masses go to the south, hit the mountains of the Elburz, and then while they are rising, they drop their precipitation. This area during the last glacial maximum was also quite important, and some exercise we have done with modeling and looking at pollen diagrams shows that clearly it's an area of refugia for plants and therefore also for animals and humans. And for example, in this part of the world, we still find the tree, Parosia persica. It's endemic now in this region, but we have to remember that it was common in Europe during the Quaternary, where it disappeared probably in the Holsteinian. But nowadays it's only found in this refugial area south of the Caspian Sea. The Caspian Sea, so it's one of the largest water bodies on the Earth, and its history of water level changes is still relatively poorly known. So I've made here a compilation from the literature, from the last glacial maximum to the present, and we can see that in general we have high water levels in the late glacial, and we have intermediate levels during the Holocene, with some periods with very low levels in between the late Pleistocene and earlier Holocene. These water levels changes are very important for life in the south part of the Caspian Sea because it affects the width of the floodplain. So as you can see on this Google Earth map, we have the mountain coming quite close to the sea. The Caspian Sea is here, and we have a very narrow coastal strip here. It's even said that at some period about 1,500 years ago, when the level was very high, one guard was enough to stop the passage from left to right. So I'm going to speak about two new sequences that are located here in the southeast corner of the Caspian Sea, and I will compare it to what has already been published, which is called to TM nearby, and two deep sea cores, GS05 and GS18. These new cores are relatively exciting because preliminary work indicates that probably we have the last glacial maximum that so far we haven't reached in the three other sequences. This is a detail of the southeast corner of the Caspian Sea. We are at the border with Turkmenistan. We are in Iran here. This is the high mountains, and in pale gray, this is the coastal plain. The two cores are located here near this bay, which is close by a spit. And one of the aims of this research is to compare two results that have been obtained a long time ago from two caves located here. So these caves were studied in the late 40s, O2 and Belt caves, and this preliminary work indicated that probably the infills dates back to 14,000 years ago. So Mesolithic and early Neolithic population were present there. And it's also a place where the earliest burned clay has been found. Not pottery, but burned clay. So like a step before making potteries. What is interesting for this talk here is that the archaeologists found layers with very different faunal assemblages. Sometimes you have seal and deers, so more marine-oriented kind of fauna, and sometimes you have a drier one, gazelles and aurochs. And later on, of course, sheep and goats are coming in. So for us, it's very important because McBurney, who was the archaeologist working there at the time, proposed a hypothesis that these changes in fauna were linked to the width of the coastal plain, so linked actually to the history of the Caspian Sea level. And this is part of the reason why we did this work, to make the link between the food of these people and the Caspian Sea levels. And new research is going to start in those caves, now this coming summer and next summer, by Canadian archaeologists with Iranian colleagues. So the questions are really, it's an old question: establish the Caspian Sea levels, past vegetation, compare the results to the new excavations, something we cannot do yet because it's not started, and finally check what I call the McBurney hypothesis, the change of food linked to the Caspian Sea level changes. I can really today address the first of these three questions. So we have two sequences which are 17 meters long. Mostly they are clay, so this is this darkish color. This middle whitish color is sealed, and at the top and the bottom of those sequences, the two sequences, we have more sandy layers. So the pollen diagrams I have obtained, fortunately or unfortunately, cover what is in red here, in both cases here, And the yellow is a parts which the pollen are not preserved. So it's quite disappointing on one hand, but on the other hand, I have had that in another sequence in the region, and quite clearly, this sediment without pollen preservation reflect low levels of the Caspian Sea, oxidation of the sediment. Now let's look at the dating. So in gray is uncalibrated dates, and in red is calibrated. So this is quite promising, and we think we have the last glacial maximum somewhere at the bottom here, and then mostly in the part where the pollen is preserved, we have the late glacial and the early Holocene. So the method I'm using is a combination of information derived from pollen on terrestrial cover, a little bit on fungal spores and parasite eggs to look at the presence of large herbivores, which are very important for Mesolithic and Neolithic people. And then also, fortunately, in the Caspian Sea, we have the anoflagellate cysts, which tell us about the water, and especially recent research we have done in collaboration. Dinocysts are very good indicators of paleosalinity. So first, diagram about pollen grains derived from land. And we have at the bottom here, the blue section is the Burling Alleröd. We have a relatively clear younger dryers with this drop of AP and AP, which is the drop of tree. And then a recovery in green, that's the Holocene. But we have a problem with the radiocarbon dates, and it doesn't, the story I'm just telling you based on the pollen diagram doesn't fit the preliminary dating we have. And to make sure that we are not wrong with the pollen interpretation, I compare now to the records we obtained from the South Basin and also from the Middle Basin. So during the late glacial, we have, in both cases, a very open landscape. In this coastal site, the sequence I'm presenting here, we have slightly more poaceae. That's probably because of the lagoonal setting. Then the younger dryers, clearly we have a maximum of Artemisia that fits quite well with the two marine cores. And afterwards, we have a period where the climate becomes warmer. We have some shrubs with more trees here because we are very close to the mountains, less trees in the open sea, of course. And finally, after 8,000 years ago, we have really an intensification of the tree cover. So that leads us to suggest that the dates we have, even the calibrated dates, are wrong by 2000, and that's probably linked to a problem of a reservoir effect, which is something quite difficult to tackle in the Caspian Sea. It has been recognized as a problem before. Now, in relation to the human story, we are focusing on the signs of erosion and the content in fungal spores. So we have fungal spores present everywhere, with also glomus, which is a sign of soil erosion. We have a series of spores related to the presence of herbivores. So we have lots of erosion and lots of fungal spores everywhere through the diagram, except in one phase here. So this is the younger dryers, and we are just before the younger dryers at the end of the Burling Alleröd. So to try to explain this, we move to the diagram where I've brought together all the elements telling us about what's happening in the water. And just before the younger dryers here, we have this phase with a lot of algae, Botrycoccus, a high number of dinocysts, and really clearly we have a strong phase, a very aquatic phase, where most likely the coastal plain that the people need to live on was extremely narrow or has nearly disappeared. So the water level was probably close to the mountain, and that probably corresponds to the layer we have seen in the cave, where people were able to hunt a lot of seals. And we are here still in the Valerian. Valerian is the high water level phase recognized in the Russian literature. It's a phase where the Caspian Sea levels are very high due to the melting of the Eurasian ice sheet. The next phase I would like to highlight your attention on is this phase here, where we have actually a change in the sediment. It's more gravelly mud, and we have a drop of all the aquatic indicators, and most likely this can correspond to the Mangislac, which is an early Holocene phase of very, very low levels in the Caspian Sea. So at that point, we have a large floodplain, and most likely the Neolithic people were able then to hunt the herbivores occupying this floodplain. If we compare the diagram from a sequence I present here to a core not too far from there, which is already published. Châtelet is only 8 kilometers from the mountain, whereas the one published earlier, core TM, is 44 kilometers. So what we have, at the beginning of the Holocene, we have actually a lot of trees, already trees actually in the Younger Dryas and before the Younger Dryas. And that's because of the proximity to the glacial refugia. In the core which is further away, we have a few trees, but in smaller proportions. What's interesting also is that we have here very low levels illustrated in this core by the absence of a preservation of pollen grains and the presence of gypsum also. So I think we have this also in this core, although we don't have dating, but that will be for a next talk when I can speak more about the remaining analysis to be made on top here and remaining radiocarbon we want to obtain. But I think it will be the same story then in this core. So a mid-Holocene drop in the water level. So in conclusion, we have a problem with the radiocarbon dates. Already we know that from other sequences it can be a big problem, but it seems to be here even a larger problem, probably linked to the lagoonal setting. We have, since the beginning of the diagram, Bölling-Allerröd, we have a lot of trees, a very diverse woodland, even through the Younger Dryas, and that means it was a very good refugia for not only plants but also humans and animals. And the model data I showed at the beginning now are really confirmed by data. Finally, we have recognized some significant changes to Younger Dryas in the terrestrial vegetation and also significant changes in the water level in the Caspian Sea, sometimes much higher than the present, sometimes much lower than the present. And finally, in relationship to human occupation, it was favorable throughout, except perhaps one period at the end of the Bölling-Allerröd when we have a very narrow coastal plain. Thank you very much.
Thank you very much. First, I would like to thank the organizers for having accepted this communication concerning our last research on the Ebro Basin prehistoric occupation since the Magdalenian to the Neolithic times. And, first, the Ebro Basin is one of the main river basins in the Western Mediterranean area. It's roughly 80,000 square kilometers, and it occupies the northeastern part of the Iberian Peninsula. It is very well limited to the north by the Pyrenees, which corresponds also to the French frontier, and to the south by the Iberian ranges. Concerning the present climatic conditions, the Ebro Basin has temperatures that are conditioned by mainly altitudinal gradient, but they are also related to the longitude. They are colder in the northwestern region, influenced by Atlantic climates, and warmer in the Mediterranean eastern part of the basin. The precipitations, as you can see, are very irregular, mostly in central and in the central and the eastern part of the basin. The wetter region corresponds to the Atlantic Northwest and to the Pyrenean ranges, where humidity declines from west to east. As a consequence, hydric balance is negative in all the central basin and in the southwestern zone of the Iberian ranges. This highly contrasted climate, typically Mediterranean, has conditioned the current environment and, of course, the current landscape. As we have seen, present-day Ebro Basin shows a wide series of different environments, from deciduous forest to high mountain pastures, desert-like terrains, middle mountain Mediterranean areas, and, of course, humanized territories exploited for agricultural purposes for several millennia. There is no, as you can see, geographical homogeneity. But at least since Magdalenian times, archaeological data shows striking similarities along the basin. Human groups shared cultural traditions, lithic styles and raw materials, and, of course, similar ornaments. Columbella rustica, which is a Mediterranean sea snail, became fashionable in Mesolithic times, and they appear in many sites next not only to the Mediterranean coast, but, as the map shows, these Columbella rusticas travel upstream of the main western Mediterranean rivers, the Rhone and the Ebro. Columbellae are very common in the last hunter-gatherer habitats, and they can even be used as a fossil director of this period. Our knowledge about the Ebro Basin period has been built mainly in the last 40 years. This was the situation in 1977. Less than 10 sites had been completely or only partially excavated. And this is the situation now. Today, there are more than 40 sites that have been found and excavated, although, as you can see, their geographical distribution is sadly very irregular. We will address this point later. And concerning the fortitude and weaknesses of this situation, as you can see, we have a historic panorama which is still under construction. There is a lot of work to do, but fortunately we are not dependent of old historic cliches and classic classifications. The immense majority of the sites have been excavated with modern methodologies. We've got accurate archaeological sequences, many radiocarbon dates, and also for every site a wide range of specialized studies. Also, most of the sites have been excavated by research groups that were formed in the same archaeological tradition, and so they share common methodologies. They also make frequent exchange of data and easy collaboration. But sadly, we have a lack of territorial research strategies. There is a concentration of sites in particular areas that are due to a variety of reasons. The purely archaeological data can be framed in a growing amount of paleoclimate sequences. These are the most important ones for the studied period. From north to south, El Portalet, which is a pit bog in the high part of the Pyrenees that helps to explain high mountain climates and can be also used to describe the Atlantic-influenced western part of the basin. In the middle, you can see the Estanya Lake sequence that informs us about the climate of the Pre-Pyrenean middle mountain ranges, and to the south, Villarquemado, which is the main proxy for the Iberian ranges. As you can see, those sequences suggest that Magdalenian and early Mesolithic hunters lived in an open or mixed landscape, and that middle and advanced Mesolithic groups had to cope with a forested environment. Hunted game, also conditioned by local landscape features, for example, some sites next to rocky terrains show an intense hunt of ibex, confirms in general trends this evolution. This slide shows the preliminary data concerning hunted faunas in the Arba de Biel sites along the studied period. Horse and bovids suggest an open landscape, while red deer implies the presence of forest. The size of the silhouettes of the animals is proportional to the recovered bone assemblage, and as you can see, it confirms that in the earliest times there was an open landscape dominated by horse, and in more recent times is the red deer the most hunted animal, suggesting a forested landscape. And now we can question ourselves which is the current situation of our knowledge about the prehistoric dwelling patterns in the Ebro Basin. Fortunately, our research team includes 3 excellent geomorphologists that have classified the currently known archaeological sites according to their location and main features. They have classified them in 3 main types. The first one is related to middle mountains with a rock shelter type in Fulvocastic Canyon, another small shelter in front of structural cuesta, and Tafoni in monoclinic sandstone. Second, shelters in lowlands in the central part of the basin. There are cliffs of paleochannels, reliefs and mesas, narrow and extent paleochannel reliefs, and large Tafoni in paleochannel relief. The third one is open-air sites. We will see some examples now. From the first type, Fulvocastic Canyon in the Guadalupe River, Angel, and in the Pyrenees, in the central Pyrenees, the big cave of Chavez. The second type, a small shelter in front of structural cuesta, Achoste, near Vitoria, in the Alaves area, and Los Baños in the Martin River. Martinari is an example next to Achoste of Tafoni in monoclinic sandstones. And now in the more central part of the basin, the lowlands, as examples of cliffs of paleochannels, reliefs and mesas, for example, Espantalobos near to the city of Huesca, south of the central Pyrenees, or Pano del Pulido next to the Guadalupe and also next to the Ebro River. The only example we've got of narrow and exempt paleochannel relief is Valstrevera, which is in the Arba de Biel area. As example of large Tafoni in paleochannel relief, we've got Rambla in the same Arba de Biel basin as Valstrevera, or Pontet, that is one of the classic sites of the Matarraña River. And last, the only example of open-air campsite is Cabezo de la Cruz, which is next to the city of Zaragoza, slightly 25 kilometers to the south. But, as we have said, this image is far from being true. We think that open-air sites should have been at least as frequent, if no more, than the rock shelters of caves. We propose here some ideas that can help to explain this situation. Arba de Biel is an example of a combination of archaeological efforts focused in a small territory where researchers have been working for some years, and the collaboration of local aficionados who have informed us of possible locations of archaeological interests. This is the Peraltilla sandstone outcrops in the Somontano at the southern footsteps of the Prepyrenean ranges. That is a good example of a potential area for finding prehistoric occupations if we apply the traditional rock shelter cliché. But erosion in the last millennia is also responsible for the scarce open-air pre-Neolithic sites. Those hunter-gatherers groups were extremely itinerant, and their campsites should have left minimal imprints that have been destroyed or totally covered by thick layers mobilized by erosive processes. On the right, you can see an example from the site of Samitiel, not far from Huesca, which has very thick Holocene fields in this slope. It's a site which is dated to the Advanced Neolithic. On the left, you can see that rock shelters do not escape from geomorphological problems. As Peña and Echevarria propose in this scheme, sandstone paleochannels can evolve quickly until being almost invisible in a very short period of time. Another issue, especially in the plain areas of the Central Basin, is the proliferation of irrigation agriculture since the middle 20th century, with modern techniques and big machinery that have deeply transformed the natural terrain, flattening reliefs and filling depressions to obtain flat cultivation lands. On the right, in green, you can see the irrigated areas in the Ebro Basin, and in the left, you can see a nice photograph that combines natural erosion in this area with artificially planed landscapes with irrigation structures and channels, water reservoirs, well, a lot of structures that have modified deeply this area. And a final question arises. Are we responsible of muting prehistoric information? Many recent researchers stress the importance of radiocarbon as a source for the study of the human population. But we must be aware that radiocarbon dates depend on factors that are not only related to prehistoric events. And we show here the example of the Arba de Biel area, where 5 sites excavated since 1999 till now have provided 35 radiocarbon dates, and the Matarraña, with more than 10 sites, whose excavations began more than 60 years ago and stopped in 1990, that have only provided 13 radiocarbon dates. This image shows that the Matarraña should have been far less populated than the Arba de Biel, which it is not true, of course. Finally, we will offer 2 different maps. The first one includes more than 70 accurately dated sites from the Magdalenian to the Neolithic in the Ebro Basin. You can see their distribution. And the second one shows more than 50 excavated or surveyed archaeological sites that have no radiocarbon dates or that provided less accurate dates. Many of them share the same areas than the well-dated ones, but others could help to fill some of the gaps we still have in the map. And here you can see a comparison of archaeological materials from these 2 categories of sites. To the left, the well-dated ones, and to the right, the others, the inaccurately or undated sites. We must conclude that, although important, dates should be a help to understand the past, not only our main objective. And to conclude my talk, these are the main ideas proposed in this communication. We have a very partial knowledge of the prehistoric Ebro Basin. There are many small areas relatively well studied, but wide, huge territories with virtually no archaeological information. The explanation should be obtained from at least 2 main factors: the unsystematic research, which besides has started recently, and some environmental constraints. Also, as archaeologists, we should not overlook archaeological remains that inform us of ancient human occupations. We can classify in narrow periods many of the assemblages that are undated or poorly dated. And I hope to finish, there is still a lot of work to do, but if we compare what we know now and what we knew 40 years ago, we can be confident in the future. That's all. Thank you very much.
Why did you think that campsite should be more frequent?
There is a lot of constraints in finding rock shelters, especially in the central areas of the basin. Rock shelters are far more common in the mountain ranges that surround the central basin, but the central basin, for example, has plenty of flint outcrops that were exploited in prehistoric times, and for prehistoric people, being limited to those marginal areas with perhaps less flint, for example, or other resources, for us is a bit surprising. The problem is that open-air campsites, if they were in the central areas, are almost impossible to find because we have fillings of 10 or 15 meters since Holocene times. So it is a guess, it's not a certitude, of course, but many ideas, many suggestions point to the frequent presence of open-air campsites, and flint is one of the main explanations because in the surroundings of Zaragoza, the presence of flint outcrops are enormous.
We would like to thank the organizers for giving us the opportunity to show you part of the results of this new research line that we have recently started and in such an impressive place. What we are going to present is just an idea, merely a hypothesis that needs to be contrasted. So we think this is a great forum to explain our work hypothesis in order to collect any idea, solution, or comments you will share with us. If you don't mind, I'm going to read in order to try to be closer to the timing. Well, first of all, we want to show you the geographical frame in which we work. This is the Middle Ebro Basin in the northeastern part of the Iberian Peninsula. As you can see in the picture, this territory is located between two main coastal zones, Cantabrian and the Mediterranean. The Ebro Basin is the perfect way to communicate both areas, being circumscribed by two important mountain ranges, the Pyrenees to the north and the South Iberia system to the south, giving the basin a characteristic triangular shape open to the Mediterranean, as you can see here. So the Middle Ebro Basin is not a natural frontier, but a communication way between the Cantabrian coast and the Mediterranean region. And it is also the easiest pathway to the plateau throughout the Cologne Basin, connecting the three different territories, Cantabrian coast, Mediterranean, and the inner part of the peninsula, being the Ebro Basin a fourth area itself to be considered. The Mesolithic period has been deeply studied in our geographic frame, as you can see in the next slide. In the next slide, and we have already seen on the previous brilliant presentation. So, as a natural outcome of all this fieldwork, there are quite a lot of publications, papers, monographs, Congress proceedings focused on the Mesolithic side of the Ebro Basin. In this map, you can see a geographical distribution of the Mesolithic geometric sites of the Ebro Basin and the different landscapes. But we have no time for this, and we have already seen in the previous presentation, we are going to pass to the next slide. Once defined the geographic and chronological frame of study, we are going to describe the starting of the artistic component, the so-called Pachypodous motifs. As you can see on the slide, there are three different stylistic classifications for Levantine human figures, according to different moments on research and different scholars. But from a global point of view, we can see that there are some basic common faces with different names. We are going to focus our speech on the first group, the so-called Pachypodous motif. So, the main morphological or stylistic characteristic for pachypods are thighs are quite bulky, as you can see on the slide. Heads used to adopt a pyriform morphology with a medium hair or maybe a hood. They are clearly dressed figures, in every case, with trousers, boots, and maybe also hoods. They appear marching with open legs in an angle no less than 50 degrees. They carry bow and arrows, but in some cases they also carry boomerangs or slings. On this slide, you can see the territorial distribution of the Pachypods motif. It is an absolutely constricted topic to the area of the Lower Aragon, Lower Ebro, and Maestrazgo, and it is a quite reduced territory attending to the global Levantine dispersion in the Iberian Peninsula. In this other map, you can see the main different Levantine areas, and the Pachypods figures are only represented on one of them, Zone number 2 on the slide in blue color, Bajo Aragón, Maestrazgo, and Baixebre, distributed in 3 different provinces or regions, Teruel, Castellón, and Tarragona. When there are superimpositions between motifs of different types, pachypods are always under any other human motif, so they seem to be the oldest one. Well, referring to antiquity of the motifs, we can see also we can also point out some aspect that highlights the thematic as a chronological value. We have no time to discuss this question, but we think that if the Levantine rock art begins in the Mesolithic with those pachypods representations, hunting actions will not be such a special fact to be depicted. That is the normal activity in hunting societies. Only from the Neolithic, with a different socioeconomic society, it could be something more or less exceptional. So for us, the novelty about pachypods, something that makes the difference, and it's so important to be depicted on the shelters, is that they had to go at full speed and running, and with the whole family, as it is represented in Centelles, for example. Here we have some tracings from Centelles rock shelter in Castellón, in which we can see a large number of people marching, carrying along with them all their possessions. There are some motifs that go heavily loaded, and it is also possible to see some of them carrying little children on their backs, as well as a child marching next to the adults. Here we have some examples of adult motifs from different rock art shelters carrying little children or babies on their backs. It is important because it shows that it is the whole group marching and not just some of the members. This map has been elaborated attending to the direction in which pachypods, walking or ever running, were depicted on the decorate panels. After this, we can conclude that the most part of them were oriented going up the basins or rivers where rock art shelters are located, always to the interior zone, to the Maestrazgo. So we think that this trend could be explained because they could be the same groups occupying a large territory where they move around, or maybe because of the economic and territorial conflict factors that could be aggravated by an aridity crisis relating maybe to the 8.2 event. On this other map, we can see the distribution of the pachypods rock art shelters and those Mesolithic geometric sites. The red circles correspond to a 10-kilometer diameter area around Mesolithic sites. It seems to be a sort of relationship between pachypods rock art shelters and Mesolithic geometric sites. During phase A, geometric Mesolithic with trapeze, there is a high occupation density in Lower Aragon. In 2009, we published, according to the radiometric dates of that moment, that this situation changes in absolute terms within phase B, Mesolithic geometry with triangles, forming a real archaeological silence of about 500 years that we couldn't explain. Nowadays, with a large corpus of new dates, that radiometric silence has been reduced to just 200 years, thanks to new dates and also thanks to new dating systems like ultrafiltration. As you can see on the graphic, there is a real emptiness for that moment in Lower Aragon, but not in the Maestrazgo. Nevertheless, despite that there are new dates, there are still occupation levels perfectly sealed by sterile levels, as we'll see in the next slide. So when we don't have dates, we document in different sites a real lack of occupation levels, sterile in some sites for that moment, with a special incident in Lower Aragon, as you can see here, levels that see completely those underlying with human occupation. In this new map corresponding to the phase B, geometry with triangles, we can see a real emptiness in the Lower Aragon, the zone with the highest evapotranspiration level comparable to Almeria's desert, as you can see here. Oh, sorry. As you can see here. But not in the Maestrazgo. That is, you can see it is occupied on those green areas marked by a higher humidity. But where do they go from the Lower Aragon? We had two possibilities. They could have gone to the north, to the Alto Aragon, or to the south, to the Maestrazgo, where human occupation is documented in several sites. Well, according to the archaeological remains, microlithic types, those sites in Alto Aragon have their best parallels influences in the north side of the Pyrenees, as you can see in the dark blue chart. But on the contrary, for those sites from Lower Aragon and Maestrazgo, they are influenced by the Mediterranean coast with some specific macrolithic types, like Cocina triangles, as it can be seen in the light blue chart. That's why we think that those people move on to the south instead of the north. There is a recent proposal by Mr. Bader that tries to explain the distribution of Pachypodus motif in correlation to raw material resources, particularly with evaporitic flint. After Bader, the Levantine artists should be the same who were looking for that specific flint in order to create leaf-shaped tools. According to this idea, there should be a connection between flint resources, chalcolithic leaf-shaped sites, and Pachypodus rock art shelters, something that tries to capture in this map, also creating possible communication routes. Well, a new publication focused on the site of Arenal de Fonseca, Angel 1 and 2, is going to see the light in the next weeks. Meanwhile, in one of those sites, there is a Levantine panel with Pachypodus figures on it. Right at the foot of the decorated panel, there are different occupation levels. The most important date in the Mesolithic, one of the macrolithic and the other one geometric. But what is more important, we have documented that Angel 1 was abandoned after the occupation of Mesolithic geometric level 8C. As we can see on the slide, and according to the date, there is an abandonment of Angel 1 around 8.2, and there is no Mesolithic occupation until level 282 of Angel 2 in 7940. So there are around 300 years of abandonment. And when the new people occupy this shelter, they carry in a significant way a new type of flint. So the search of this type of flint cannot only be assigned to a recent moment, chalcolithic, as Father said. On the contrary, we have observed that this tendency is in the use of non-local flint begins in the Mesolithic geometric and carry on during Mesolithic. I don't know what's happening with the presentation. Let me see. It doesn't work. No pasa. Sí. Bueno, ok, lo hago así. Okay, it is remarkable a main use of local resources from Gravettian, almost 100%, to Mesolithic macrolithic, as you can see in the slide, but there is a change in the trend from Mesolithic geometric. This graphic corresponds to the levels from Angel 1 and 2. The use of the evaporitic flint with a large grain size can be related to a heat treatment of the flint before knapping, something specifically indicated to obtain double bubble macroliths, something that has been already pointed for some other sites, like those in Biel, studied by Montes and Domingo. Well, several gaps are shown in this slide. The more evident gap is the one related to Catalonia, where there are no Pachypodus motifs. For the area in which we focus our study, Lower Aragon, we can see up to 3 different gaps. One of them coincides with the 8.2 event moment. So finally, as we have tried to show, we think that Levantine artists, creators of those Pachypodus motifs, tried to paint on the rock walls that they had to move. And we consider feasible that the reason had to be with the aridity, but not only with cold weather. That's why they had to go to from the Lower Aragon to Maestrazgo. And we have different variables. Lower Aragon, abandonment in 8.2. At the rock art motif, they seem to be shelters with trousers, boots, and hoods. Aridity crisis of the 8.2 events could be the trigger effect for human movement, and also the search of evaporitic flint could have been an important factor. To sum up, it is possible to think about 8.2 event as the main cause of a game scarcity, a probable drastic decrease of the animals to be hunted in some areas, like Lower Aragon. So hunter groups had to move to other areas with a much more propitious environment. But in any case, this is just a proposal, a hypothesis, an idea. We saw it according to our current data. Theories can change and move as people do. So we have more questions and answers than answers, and maybe this Congress could have some responses. Well, thank you so much for your attention and patience.